Yeah. All right, here we go, guys. I know that last question is probably a little bit freaky, but I was hoping this might help you think about it. So this question right here, would you say that the groups of data, if you look at the groups of data, are they all the same? No way. No. Does that agree with what you found here? No. Just looking at the centers, you wouldn't have a clue that the lists of data are different. And then I have you do this, and then I ask you, the measures of the center don't show the differences. We know that's true, because we know they're different, but they all came out the same for the first problem. What are the look at this. Look at the distributions. Which distribution is the most spread out?
C.
No. I know why you say C. I know you do. But let's really figure out what I mean by spread out. I can find the middle of some data. Like, for example, I have a group of 3 friends who've been friends since high school, and we try to have a reunion every couple years, right? And we live so freaking spread out. One's in Seattle, one's in Richmond, one is now in Phoenix. He used to be in Minnesota. Probably happy he's not there. And then there's me down in San Diego. So if I wanted to know, okay, where should we meet? I'd be curious about the middle, sort of like figuring out a middle. You guys with me? And then each of us would be worried about how far we are from that middle. Does that make sense? Because then that would tell me how much the plane's going to cost and all that kind of shit. You with me? You guys kind of with me? You guys
Yes.
with me? Okay. I like that. Go on. We got you. So which one of these lists of data get furthest away from their mean? Okay. A is the one that doesn't get very far from its mean at all, right? 8 of this data points equals the mean. So this is the one that has the least spread. There's a couple of people that escaped, but everybody else is freaking right there. Here, more people escaped. It's getting a little more spread out. Here, there's like an even distribution. It's a little more spread out. Well, here, look, there's 3 at the extremes now. And only 2 in the middle and 1 right there. So that's the most spread. So if I could come up with the way to calculate the spread, a number that represents the spread, and remind me, think about this. What was spread? What are we trying to define spread as? This is what it is. You ready? This is the spread. Oh, you know?
Are you asking about standard deviation?
I am. I'm just not using that word yet because that's a little technical. It will be called the standard deviation. Is the spread. The spread is going to be the average distance every data point gets from the middle. You guys with me? Kind of makes sense. Here's the middle. If everybody's there, the spread would be 0. But the minute I start pulling people apart or people leave and they go somewhere else, the spread gets bigger. That does jive with the idea of spread in general. Are you guys with me? Now, let me say something that should interest you a lot. Do you guys know about that website, Rate My Professors? Okay, you guys use it a lot probably to figure out who to take. I love it. In fact, I'm thinking about putting together a statistical analysis of the Rate My Professor to see what percentage of comments actually talk about how well people teach versus what they let you do, what they let you get away with. You with me? All right. I haven't looked at it in a while, but I got some bad ones, which is good. I want some bad ones because I got bad students sometimes, and I want them to hate me because that means I'm doing my job. But do you guys know? So there's that website, right? Do you guys know about the website that tells you grade distributions of teachers?
Oh, that seems more valuable.
So again?
It seems more valuable.
A little bit, maybe. I know everybody wants to take the one that gives A's, but me, I always want to take the one that could actually make me understand shit, but I won't. There's those 2 opposing viewpoints. There is a website, I'm not going to tell you what it is. You actually have to pay a little money, thank God, but it is public domain knowledge. You could actually, if you had some balls, you could call the college and say, give me the grade distributions of this teacher, this teacher, this teacher. And they have to. Public domain knowledge. So this website capitalized on that. They contacted all the colleges. They get all the data and they put it together on this website. You pay a little money and you can see all the grade distributions. Are you guys with me? All right. Okay. So use that information however you will. Now, got you all interested, didn't I? So let's say you want to take some course. and there's these two teachers that their times work perfectly. Everything about these two teachers, they're clones of each other, right? In most respects. Everything else is the same about these two. They both give an average of a C. They both do exactly the same grading. All this stuff. You guys with me? Everything else is the same. The one thing that's different is teacher A, well, let's not call him teacher A. Bob gives B, C's, and D's. And let's say you're at university where D means you actually passed the course. Think about that, when you're driving buses. Hopefully the D person in there. So they give B, C, so B through D. And then the other teacher, that's Bob. And then Alfred gives A through F. You guys with me? Which teacher would you take? Well, it depends on something, right? So one teacher basically never fails anybody, but also never gives any A's. And the other teacher just gives every grade, whatever. So when would you take the B through D? When would you take Bob? Yes, if you're worried you're not going to pass, well, this guy never fails anybody, right? So you're like, I can live with a D, I just need to pass this damn thing. When would you rather take Alfred? Bob doesn't necessarily not teach well, right? But normally, because he doesn't give any freaking A's. I had this, anyway, I'm a little bitter about this one experience, but he was waiting for freaking God to take the test. And then even then, you take the class, even then he would have gotten an A minus. But stay with me. I'm going to take Alfred if I know I'm going to kick that class's ass. Then I want to get that A that I deserve, right? You guys with me? So what's the difference? The middle was the same, C's. In fact, I know they're both exactly a 72. That's what they give the average grade. But then I add this other information about the spread of grades. Without that extra information, I can't really make an informed decision. So what's the two best numbers to summarize any group of data? The mean, middle, and the standard deviation, the spread of the data. Those two numbers together summarize the data quickest. I have a kind of a visual of the data then. All right, so let's see. Remind me what the definition is of this spread. Let's see who remembers. How do we define spread, which I'll go ahead and call standard deviation? Don't worry, we're not going to do too much more. We only got a few more minutes. What was the definition of this again?
Average distance every data point gets from the
I love it. Yeah. So the average distance from the means every data point. So I'm just going to get the idea started about how to do this, and then we're going to see how to do it. I don't want to say this phrase. This phrase right here, next time, that's when everybody kind of like starts to back up. We're not quite ready yet, so just hold on. So we'll talk about the actual formula next time. But right now, how do I find the average anything? If I wanted to find the average age of all the men in here, what do I have to do first? Get a list of all the men's ages. If I wanted to find the average miles per gallon for all the cars in the parking garage, I have to first get a list of all the miles per gallon for every car in the parking garage. I have to first get a list of those. So here I want to get an average distance from the means every data point. So I need a list of distances each data point gets away from the mean. So for example, look at, let's do group C. Here's group C, 6, 8, where do you go? 10, 11, 13, 13, 15, 16, 18, 12. Okay. Now, how do I get the distance away from the mean to each data point? What would I do? What operation, of course, does distance imply?
Take the absolute value of the difference.
I love it. No absolute value. Don't say that yet. It's going to come into play in a minute. So if I take the difference between these two, then I'm going to get kind of a feel for how far away everything is. And the negatives would just mean that they're below the average. So there is kind of value in knowing the negative, but there is going to be a problem. So if I do that, what was the mean? All the mean, everything was 13, right? So this would be -7, -5, -3, -2, 0, 0. 2, 3, 5, 7. What do those all add up to be, though? And this is where the absolute value kind of idea would come in. Is everybody cool with where I got this from? Right? Because it's every data point minus the mean of the data points. So that's 7 below, that's 7 above. If you add them all up, you're going to get 0, which sucks, because the average distance should take all the distances, add them up, divide by how many, but you're always going to get 0 then. Okay. So I could do an absolute value, but the problem with absolute value, without getting too deep into it, one big problem with absolute value, who knows what an absolute value looks like as a graph? V, I love it. Is that a plane you want to be on? Right? Right here, we're all dead. That's, we can't handle that kind of a sharp turn. So that seems very non-mathematical, but it's completely mathematical. This point right there, that is a kink. That is difficult to work with mathematically. So absolute value would be the natural place you go, because remember, absolute value meant distance. That's why it's always positive or 0. Right? You remember that? What's another way to kind of get rid of negatives if I don't want them? What other thing makes it always come up positive with real numbers anyway? Instead of taking absolute value, I can do what to them to make them positive? Square them. I love it. So this is where I'm going to stop. The next time we'll get into, if I square these, what am I going to have to do at the end? Square root them. Because right now, if these are dogs, I've got square dogs here, and that's just freaky. That's some weird shit. Keep that away from me. What happened to that dog? Right? So at the end, we're going to have to square root it. But this is just, why do I square? To kill the negatives. So I don't have some freaky kink in my graph. So next time, I'm going to have a handout all about this standard deviation. Don't forget the quiz, too, next time, first thing. And I'm going to have the practice test next time, because the first test is a week after this Wednesday. Holy shit. Okay, don't forget your stuff in my calculators, please.